Hello, hello. Oh, yes. Hello, hello. Okay. Hello, Gabriella. Hello, Vivian. Hello, Melissa. Hello, Jayla. Hello, Vivian. Or good afternoon, Vivian. Oh, thank you. Oh, wow. Okay. Um, that's amazing. Okay. Good afternoon, Jayla. Good afternoon, Alyssa. Good afternoon, Vivian. Good afternoon, Lakshmi. Good afternoon, Gabriella. And lobsters also wish you a good afternoon, my huge, enormous collection of lobsters. Good afternoon, Jaylin. Good afternoon, Nicholas. And associated humans. And wait, there's more people coming, and I've just made them wait. Sorry. Oh, I guess oh, sorry. I guess I started a little bit early accidentally. Sorry about that. Nobody's late. I'm just early. Okay. Or I'm late for going back in time. So what I say, good afternoon, human. Good afternoon, Charlie. Good to see you. Oh, and more people coming. Sorry. Okay. Good. Hello and good afternoon, she. Um, good afternoon, Mark. Good afternoon, Andrew. Good afternoon, Brenda. Awesome, awesome. Okay. Good afternoon, Catherine, with an I. You know, there's no I in team, but there is a me. If backwards or something. Okay. Oh, wait, hang on 1 second, sorry. I'm hearing there may be an interruption in a minute. I'm hearing tremblings somewhere else in my house, but hold on. Okay. Okay. So good afternoon. Did I said Catherine? Okay. And good afternoon, Stephanie. Awesome. And also a special, well, okay, we're gonna get started in a second. We are gonna get, wait, okay. Wait, and there's something in the chat. Good, yeah, the lobster, you can hear that sound, that's interesting. Okay, wait. Okay, wait, okay, so there is a fascinating, I do want to get started in a minute. There is a fascinating question in the private chat, but it's fascinating enough. I want to acknowledge that it's awesome, but I can see why it's in the private chat because it might be too distracting for me to try to answer it right now. Let me just think about this for a second. Well, right. No, it's just that it's a little bit ahead of, I mean, that's okay. I do want to address this. There's a question that I do want to address this, but I also don't want to get us confused. And it would be the same thing. Sorry. And if I look for, I'm just tired. I'm not, it's a great question. And as everybody can see, of course, I'm not even reading it out loud yet, which may be, let me try to ask, what? Wait, I don't even get that. It's the private chat. All right, hold on. Apparently I am a little bit tired too. There's a great question in the private chat. It is a great question. And of course, the obvious thing I should just do, whatever I'm going to do about answering it, is I should read it out loud. And I might, but I think there's even aspects of the question that may confuse other people if I even read them out loud yet, or at least at this moment. So let me say that I'm going to say some things in this class. Okay, no, it is a good enough question. What I'm going to do right now, I'm going to try to, there's a question in the private chat. It's a good question. It's a slightly confusing question. Like if I literally read it, it might throw some people off. It might throw off some understanding so I'm not going to literally read it out loud. but I am going to try to briefly address it right now, just to put what we're talking about in context. And then I'm going to say, we will say more and more about it as the class progresses. And also I'll say to that person, if they want to stay, hang out for a second after this class or some other class, I can address it more with that person. And all this, if I sound weird right now, it is partly just because I'm tired. Yeah, that Tuesday night commute is a little rough. Here's what the questions, okay. We're still talking about waves here in the class. In a way, we're going to talk about them for the rest of the class. We're certainly talking about unthingy motions for the rest of the class, one way or another, whether it's waves or fields or radiation, which is sort of ultimately the point of this whole class. We are now talking about immaterial motions through the material world. Like that's what we're talking about, right? And one big point that I want everybody to see, and a point that this question in the private chat addresses, is when a wave pulse, again, is not a thing, right? Like I keep saying that, and I think that's clear to everybody. A wave pulse is real, is super scientific, like it exists, it matters in the real world. And more, when I say it's scientific, what do I specifically mean by when I say that a wave pulse is a scientific real motion? Like what, who am I to say what's real and what's not real? A lot of things that are not scientific are real, but what I actually mean when I say that a wave pulse is within the province of science or within the province of physics, what I specifically mean is that it is measurable, analyzable, like mathematically analyzable and predictable, right? And that's a pretty important standard. That's not my standard of reality. Like I think love and justice are real, but I don't know that they're measurable, not at this stage of the world. And I don't know that they're predictable, not quantitatively predictable, right? So that doesn't mean that love and justice doesn't mean I don't believe they exist. I actually totally believe that they exist. I just don't believe that they can be studied in a science class, right? And literally that is a non-value judgment statement. Like it means we need different other kinds of tools to consider things like love and justice. We can't use the tools, the instruments of science, as far as I know at this point, to study them. Okay, now wave pulses and fields, which is where we're going with this ultimately, or radiation, these are motions through space and time that, although they are not made of particular objects, they are totally scientifically analyzable, again, meaning they are measurable, subject to mathematical equations and analysis, and they are predictable, where we can make predictions about them. Now, so they're interesting to me, wave pulses, right? What I keep trying to drum in, and what we're going to go back to today in class, is that for a wave pulse to travel, there must be a medium. I am saying that in the class, at least as of right now. I'm saying if you picture the pulses traveling back and forth along the strings of your lab 3, which are sort of our canonical, like those strings, those slinkies that we use in lab 3, along which you sent pulses propagating back and forth and back and forth. They are now to us the way a mass on a spring from homework 1 was to the study of harmonic oscillation. Like they are our canon, our vivid central illustration that we think contains sort of all the seeds of all the math and all the discussions that we want to have about anything else that is a wave. Let me say again, anything in life that is a one-dimensional wave ultimately mathematically can be modeled as those pulses that you saw on the slinky in lab 3. And so anything that is a wave ultimately acts like those pulses on those slinkies in lab 3 and satisfies the wave equation, which is in effect here at the bottom of the page, the second equation on the bottom of the screen right now. And we'll get to the top equation soon. Okay, this is a long way. Sorry, I think I am tired, but The thing that I'm saying though is just like the wave pulses in lab 3, you can't have this pulse without a medium. What is the medium? The medium is the material collection of oscillating particles. Like you need a huge collection of particles, of actual physical material entities, and you need them all to be undergoing harmonic oscillations in space and time. Like you need them all to be dancing in this highly intricate dance in order for this immaterial thing known as a pulse to travel through space from one point to the other. What I'm saying again, I'm saying the wave pulse is not material, but it cannot come about, it cannot exist, it cannot do its thing unless there are a bunch of materials sitting there doing something collective and complicated. The wave pulse is a phenomenon. It is a result of a whole bunch of highly individuated motions. Okay, so, okay, even though I've said that now like 14 times in 14 different ways, what I'm really trying to emphasize to all of you then, if you've ever heard in life that for there to be a wave, there must be a medium, and I think you probably have heard that, I mean, in scientific life, if you ever hear that for there to be a wave, there must be a medium, such as for there to be sound to travel, there must be something through which the sound travels. Like, I think you have heard that in one context or another, and I agree with it. And you've heard it to the point where you may have heard like, okay, I can make a sound in the air to you guys, or we could even get underwater and make sounds. Like, we're not saying that the medium for sound exchange must necessarily be air. It could be something else. It could be water, or it could be wood, or it could be like the nylon string of a musical instrument. But sound needs to travel through something, and therefore in outer space, there is no sound, right? Like all of that I'm standing by. I'm saying it's all true and it's important. I'm going to go one step further. I know I'm over talking this, but what I'm not just trying, and I know you've heard it before, but why I'm spending a month and a half on all of this math and all of this like breakdown is I want you to see that when people say for there to be a wave, there must be a medium, they're not just saying that as a matter of history, we've never yet discovered a wave that didn't have a medium. They're not just making an empirical claim. They're not just making a descriptive rule. They're making a prescriptive statement. When they say, when anybody says, for there to be a wave, there must be a medium, they're not just saying that's the way we've always observed things in the past, therefore we're going to induce that that's probably the way things are in the future. Like, it's not like PV equals nRT or some of those kinds of laws that we learn. And I'm not insulting that law, but many of our laws in science are descriptive, empirical, induced laws. They are generalizations from past experience. They're a statement of what we assume our future experience probably should look like based on our past experience. This is not one of those. When I say that for a wave to travel, there must be a medium, I'm not just describing what scientists have noticed in the past. I'm saying logically, I'm saying linguistically, I'm saying triple equal sign. I'm saying it literally doesn't make any sense for there to be a wave pulse unless there is a medium. A wave pulse is the phenomenological result of a bunch of particles doing this intricate thing, a bunch of particles undergoing these intricate motions that we have been very painstakingly and very seriously trying to study and understand for like a month and a half for that reason. Like, I'm saying, and I'm not yelling. I mean, I am yelling. I'm not angry at it. And it sounds like I'm angry at the question. I haven't even said the question yet. Okay, I'm not angry at the question. I love the question, but I want to make this groundwork, but the question's coming from a place. So let me remind or reinforce to everybody that place. The place is that at this point in the class, if you want to understand something in English, I mean, if you want to be picturing a takeaway in English, it is that that a wave requires a medium, and it requires it prescriptively, deductively, analytically, like not inductively, not empirically, not descriptively, prescriptively, deductively, analytically. I'm saying I literally cannot picture a wave without picturing a medium, because a wave is the result of a medium doing a bunch of stuff. Okay, like by definition, so far in this class, I'm saying a wave pulse is a highly intricate wiggle. For there to be this wiggle, there's got to be things wiggling. Okay, like, okay, so that's what we're saying so far. And also to get, I mean, for those people who would like to get back to the class or back to the questions, like we're about in the curriculum, we're about to, like, the next step we're about to take in the curriculum is to really look at some of the characteristics and implications of that medium that drives any kind of wave, such as the medium of air driving sound. We're going to take the role of the medium super, super seriously. Okay, so what's being implied here so far, or no, excuse me, what's being stated so far is that where there is wave, there is medium. And that certainly applies to your lab 3 transverse mechanical wave. It also applies to sound, which I think is the sort of more realistic or more like real world daily example of all of this stuff that we're talking about now. Okay, so and I like talking about sound because sound is definitively immaterial, but it's so definitively real. You know what I mean? Like all the stuff, like whenever I'm talking about waves, try to picture sound. Well, that's an oxymoron. Try to consider all of these math and descriptions as they apply to your experience of sound, because like they do in a very, very real way. And sound really is such a beautiful example of something that it just doesn't exist as a thing, but it totally exists as a phenomenon. Yeah. And when I say that again, I mean, like, even when I'm shouting, like you can break down the phenomenon to the level of air molecules going back and forth, but you'll never find, there's no such thing as a sound particle. If you follow what I mean, there's no such thing as the smallest unit of sound that is either here or there at a given time. And there's no such thing as like 2 sound particles that can't be in the same place at the same time. It just is not a thing. Like sound is a verb, not a noun. It's like a dance. It's not a dancer. Now, having said all that, having said, and I'm rolling my eyes at myself. Not, okay, cool. Oh, and by the way, hello, private chat people. Sorry. Okay, people that came in. Now, having said all that, and it is worth saying, yes, I'm saying all of this because of a question that's in the chat, but I want everybody to understand the question's motivating this. It's not off topic or like just to that one person. But now, having said all that, here's what the person is raising. And it's totally fair for them to be raising this. They're raising the issue of what about light? Okay. Now, in a way that's a little bit ahead of us right now, like in a way that's a little bit ahead of us. That's why I'm like stuttering a little bit or bumping a little bit. But let's be real here. Like to raise the question of light, like that's where all of these ships are heading. Okay, to everybody, the reason this is all worth talking about, and the reason the math is all worth talking about, and the reason it gets hard and abstract, and we never have quite enough time to do everything I want with this, is all of this is us trying to lay out all the ingredients on the table so that we could eventually be prepared to eat a meal called light. Like light is the ultimate punchline of all of these unthingy things and immaterial motions that we're talking about. It's totally fair for it's almost, it's fair for any of you sitting there thinking, does this relate to light or doesn't it? And if so, how? So someone in the private chat is asking about light. Now, I have to admit that I can't fully answer their question yet because there's more ingredients that we have to put on the table to really understand light. Because like the thing that we can picture right now is sound. Sound is a standard, typical, awesome wave. Light is a higher level example, and it doesn't fit all of these descriptions. So I can't totally answer now, but I certainly want to answer somewhat. Because you do, all of you, like if this is a movie you're watching, I don't mean me, but if you're watching the movie of the story of physics unfold through these classes, like it is a detective story, and you should be interested in who done it, if you know what I mean. Like you should be trying to sort of think about what the ending of this movie could be, because you are scientists and you are predictors. So let me say, the reason that someone's bringing up light is because many of you have probably heard, I mean, many times in your scientific life to this point, you may have heard all these weird things about, is light a wave or is light a particle? You may have heard that sometimes people think light is a wave and sometimes people think that light is a particle. And when I say think, I mean like throughout history or whatever. And you might have even have heard that sometimes light behaves like a wave and sometimes it behaves like a particle. Or you might have even heard that we sometimes treat it as a wave and sometimes as a particle. If you heard all those things, you're not crazy. Like I mean, they are said, all those things. Now, and ultimately, I need to address the weirdness of light. Please understand before we go any further, whatever, like, yes, those are questions that are totally, that they make light worth thinking about. Please know, if you've ever heard in your life, oh, I don't know if light is a wave or a particle, or physicists didn't know if light is a wave or a particle, or blah, 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 blah. I usually save this for later, but I'm going to do this now. Please understand, that's a very important question. That is a fascinating question. And I'm not saying there aren't answers. There are answers. But that, that question is worth like all of the attention of all of your physics courses put together to get to that question. Because and every time someone says what they think is an answer to that question and seems to close down the conversation, they're making a mistake to do that. Like that's everything about whether light is a particle or a wave should be the opening to a conversation, not the ending to it. What I mean by that is this. See, I knew I was going to get, it's such a good question. What I mean is this. When I used to hear that all the time, like in high school or in college, like, and obviously I was a physics major in college, so I heard it a lot. I always thought it was stupid. I did think it was, well, for a little while, I didn't think it was stupid. Then I got really bored of it and really annoyed how often it was coming up. Is light a wave or is light a particle? I particularly thought it was stupid when eventually I got it into classes where it seemed like they were saying over and over again, it seemed like in classes, people were saying, first physicists thought it was a particle, then they thought it was a wave, then we thought it was a particle, then we thought it was a wave, then this genius thought it was a particle, then that genius thought it was a wave. And then in the 20th century, when we had the real geniuses come forth and save us all, they brought us the models of quantum mechanics, and they showed us the real ultimate truth, which is that light is both a wave and a particle. Isn't that so exciting? Isn't your mind blown? Now you can go home, now take an exam. And I was like, wait, what? Really? Like, really? That's really? You're putting me through this torture for months and semesters saying, to me, it sounded like this. To me, it was like, first scientists thought the ice cream was vanilla. Then scientists thought the ice cream was chocolate. Then scientists thought the ice cream was vanilla. Then they thought it was chocolate. But here's the real answer that's going to blow your freaking mind that it took total geniuses to come up with, which is it's vanilla and chocolate. Thank you. I was like that. I mean, seriously, I was like, I never even understood why it had to be one or the other. Like, why did it take a genius to say it was both? Like, if you were debating it for that long, like whoever said it had to be one or the other. I mean, I didn't consciously think that, but I basically was like, guys, that's just, if your ultimate answer is it's both, doesn't that just kind of show the question was stupid in the first place? That, right? That's kind of, and I'm here to say, yeah, I thought it was totally anticlimactic. I did. And especially the more they made a big deal of it. And I'm saying I'm a physics major. Like I'm like signing up for this. And I'm like taking a lot of classes where they keep making a big deal of this. And they kept seeming so excited by it. I was like, I mean, how could you be that excited by that? Like something's wrong. Like I'm not, but here's what was wrong. What was wrong was my understanding. And of course I blame them, but what was wrong was my understanding. When I kept hearing, is light a wave or a particle? Sure, in my mind, that sounded like, is it one flavor or is it the other? And sure, there's no reason to assume that the world has to be divided into two flavors. Like there could be strawberry, for heaven's sake, or there could be a chocolate vanilla swirl, like who, but it's not a question of flavors. Like what I want to say, as long as I'm yammering about this now, and again, for those of you who are like, why is he talking about this? I would have made this speech at some point anyway. I'm just making it a little bit earlier now just because someone happened to ask a good question in the chat, which shows they're paying attention. So like, okay, so that's good. What I want to say to all of you is if you ever hear again in your life, and you are going on in science, many of you, most of you. So if you ever hear again in your life, like, is it something, a wave or a particle? Realize what they're really saying. Like what we're really saying here in this class is, it's when it comes to motion, when it comes to motion, it's not that there's two flavors of motion, particle motion and wave motion, right? If that were the deal, like there could be 3 flavors or 4 or more, who knows? We're not saying that. We're saying when it comes to motion, a motion is either a particle motion or it isn't. Wave motion is just a catchphrase. It's just a word for a motion that's occurring for which there is no identifiable mover. When we say that sound moves as a wave, what we're literally saying, like forget all this math for a moment and forget all these details for a moment. When we say that sound moves as a wave, not as a particle, what we're literally just saying is sound is not a particle. We're saying there is no such individual thing called a sound thing. When we say, right? So we're saying it's not that the two choices are, does something exist as a particle or does it exist as a wave? We're saying that when a motion occurs, there's two choices. Either there is something doing that motion or there isn't, right? This is a matter of logic, not descriptions. This is like, I'm not saying that everything in life is either a square or a triangle, but I'm saying for everything in life, it's either a square or it isn't, right? Everything is either a square or it isn't. Now, I could also say everything is either a triangle or it isn't. I can say I'm either shouting now or I'm not, right? That's logic. That's called Aristotle's law of the excluded middle. That's literally the way or at least in Western reasoning, that's like the way our brains work. We're saying I might be red and green, or I might be red and yellow, but I can't literally be red and not red at the same place at the same time, right? So I'm saying if sound is moving from my mouth to your ear, either there is a thing called sound going from my mouth to your ear, or there isn't. And to call sound a wave is simply to say, oh, there isn't a such thing as a sound particle. It's not saying sound has a certain flavor. It's saying sound doesn't exist unto itself as a discrete, identifiable, particular entity. It's saying that sound is a resulting phenomenon of a bunch of little entities doing something together, those little entities being usually air molecules. Okay, again, so I'm talking to the whole class now. I'm trying to get across here, again, how important the medium is. I'm saying that when we say that sound is not a particle, what we're saying is there are a bunch of particles that are normally just like particles of air or whatever that aren't in any way sound particles. They're just particles that are arranged in such an intricate way that it requires all this math to unpack, but that all these air molecules are arranged and arranging themselves and dancing in such an intricate way that this phenomenon, this behavior, this collective observable ripple emerges, and that ripple we call a sound wave, right? So when people say, is light a particle or a wave? That's a totally misleading way to put the question. What they're trying to say is, does light move as a particle or as a wave? And when they say that, what they're really saying is, does light exist or not? That's what they're saying. They're saying when light streams in from the bulb to the desk, or whatever, like when light comes in from one place and goes to another, whether it's a beam of light or a laser beam of light, or just like a nice like washing like atmospheric irradiance of light, whatever. When we observe light traveling from one place to another, if we were to look closely enough, would we find little particles that are like light particles, or would we not? It's literally a binary question. Does light exist or does it not? That's what physicists were scratching their head about for centuries and centuries and centuries. And that's a legitimate question, especially because like light is everywhere. I mean, it is by virtue of light that we understand everything else. So it's like kind of interesting to ask, wait, this light that's everywhere, that's coming from the stars, that's doing everything for me, this light that I'm using to do all my physics experiments, like, is it actually there? Or is it just a phenomenon? Is it just like an interpretation on my part? Like, that's a freaking legitimate question, and it's a hard question. So let me say this. when someone finally said, the reason no one would say for centuries and centuries, oh, I guess it's both, is because that's insane. That doesn't make any sense. You can't say it's both. Yes, you could say a dish of ice cream is vanilla and chocolate. Of course you can say that. You can even say, right? You could even say a dish of ice cream is tall and fragrant. Of course you can plop a lot of adjectives onto one situation and say that it's, many things. But you can't say something is there and not there, at least not as a scientist, you can't. Like, if we can say things like that, if we could say, okay, our basic elements that we're dealing, like, can you imagine starting a chemistry class with the axiom, okay, there's hydrogen, there's helium, there's beryllium. Now, hydrogen, well, it exists and it doesn't. Beryllium, well, it exists and it doesn't. Like, what? Like, I can almost understand that in some sort of really cool mystical class, but how could that be a science class, right? So you can't say light exists and it doesn't. Like, what? So, but yet some of my professors and some of your professors are saying that that's what quantum mechanics says. Now, I'm not even going to say that's wrong, but I'm going to, because again, even though I'm like taking all this time, like, you could see why this is a big can of worms. This does take a lot to unpack. I'm not saying that anything you've ever heard before on this topic is wrong. I'll say one thing though, it's wrong to think it's silly. If anything in science is interesting, this is freaking interesting. Like, it's definitely a real question. And anybody that just walks in and says, so it turns out light is a wave and it's a particle. Like, okay, you can accept that if you want, but don't accept it lightly. And don't think that you now understand. I'm not yelling at you or anybody, but if my mind is to go, oh, okay, so next, light is a wave and is a particle, I guess that's quantum mechanics. Okay, I'll get that right. And that's like, no. That's cheating. That's literally cheating. I don't even care if I put it on an exam or not. I don't care if there's a grade involved. If I literally just sit there thinking that I'm pursuing a career in science and scientific research and scientific thinking, and I just accept like, okay, so light is a particle and a wave. Got it. Next. Like, question resolved. Next. Like, that is so cheating. I can't even, like, literally, like, that my brain should not. The only way I'm allowing those two thoughts to sit in my brain at the same time is for me not to be paying attention to them. Right? I mean, that's literally just me going, I don't care. I don't care. And the reason I'm taking all this time on this question is the person that's asking the direct chat about the question, even though I'm still not yet even answering it, how could I? They're asking, they care. Somehow they're listening enough to me. And this is all of, I mean, I'm not like singling somebody out, but at least one person in class is like, okay, I sort of see where this is going, but then how does this apply to light? I kind of find the light thing confusing. Yes. Like, I am not doing my job if you guys don't, every single one of you, at least have a moment where you're like, wait, that light thing is kind of confusing. Anybody who doesn't think it's confusing is confusing themselves deliberately. Talk about gaslighting. The biggest gaslight of all is to sit there and think that we understand the world when we accept the idea that light is a wave and a particle. I'm not saying that's wrong. I'm just saying we're not in a position to just like accept that like as though it's reasonable or boring or something. Now, I'm going to calm down in a minute. But this question, I mean, I will tell you the whole reason I teach these courses, whether we get to it or not, to me, the whole purpose of all of this stuff in my life, the reason I do all this math and everything is so that I can understand light. I'm not exaggerating. Like, every time I think I come close to having, and I do think that I do have enough math in my soul at this point and enough things organized in my brain that I thought about, that I do think I have a glimpse of kind of how light kind of makes sense, kind of, but that's a big point of pride for me. Like, I'm very excited to be able to have a glimpse of light, and it's taken me this long. It is how these courses are organized, is to get each and every one of you to the point where at least you might even have to be curious to want to understand light, and then maybe you want to do more to get, but all of this is heading towards trying to understand light. Light is the central beautiful mystery of physics, and it is somewhat understood better than I'm conveying right here right now. Like, it's not an unapproached mystery, but it is wondrous. So what I'm saying is this now. What I'm saying is what I'm saying is we can't casually just say that light is a wave and a particle. In most macroscopic modern typical observations of light and measurements of light and experiences of light, it generally turns out to be a lot more useful and reasonable for a variety of reasons that I can't get into right now, but it generally tends to be very reasonable to regard light as a wave. And it is true, if you care, there's a major experiment called Thomas Young's two-slit interference or two-slit diffraction experiment from like 1804, showed that light behaves like a wave, shows that it interferes like a wave. It showed it in a highly precise way. It's not the final word on the topic at all. It's not, but it's like one of many good reasons to regard light as a wave phenomenon. But the problem is, one basic problem is, so this is where I'm going. But whenever we talk, there's many good reasons to talk about light as a wave. But the thing is, whenever we talk about it as a wave, then to bring this full circle, I'm saying to everybody, if we're going to talk about light as a wave, we have to believe there's a medium, right? We have to, if it's a wave, that means it's a ripple through some other bunch of particles or somethings that are creating that ripple. And that raises hard questions like the one that's in the direct chat. Like, I could leave the discussion there. I could say light is a wave and therefore it has to have a medium. And I don't know what the medium is, but it has to have one. And I could leave it there. But where it gets a little bit mysterious and a little bit challenging is like we see starlight, right? I mean, we see stars, which means light is coming from stars to our eyes, i.e., I mean, we don't hear stars, and it's not because they don't make noise, right? We don't hear stars because the sound, whatever sound is going on stars or whatever, doesn't get to us because it can't travel through outer space. But the light evidently can. I mean, I'm not exact. I mean, this is like a straightforward. I mean, it is this simple. Like the light does travel from stars through deep nothingness of space to our eyes. So it does raise the question, wait a second, if light is a wave, if it's a ripple, what's out there rippling? Now, I'm not, right? That's a good question. It's part of what, now, if you go around and you say, or you pick up because you sort of sounds like you've learned, if you're like, oh, I guess light is that funny wave where it actually makes its own medium, or light's a wave, but it comes with its own particles. I mean, I guess I've heard that in other classes. I just want to say that's not really good enough. Like that actually furthers the confusion. Like we can't really say that. I know it sounds in other classes sometimes like we're saying light is a wave, but it also is made up of, it's a wave that's made up of little particles, or it's a wave, but it makes its own medium or something. But no, what I'm screaming and yelling about for the last 25 minutes is, no, that literally makes no sense. Like that is not, if light made its own medium and was made up of its own little particles, then it wouldn't be a wave, then it'd be particles. Like it really is a one or the other kind of deal. So, and I'm not saying there aren't answers, but the answers are really challenging. And I'm hoping, I'm not saying we're not going to get to them either. Hopefully we are going to get to them. And maybe I've even saved us a little time for that for today talking about this, but if nothing else, I'm just trying to say, I mean, the material study of immaterial motions is fascinating and highly mathematical exactly for this reason, because really mysterious things are afoot. They're not just things that challenge our curiosity, they're things that challenge the way our minds seem to work. Like to really understand light, you really have to investigate why is it that the human mind doesn't want to think that something is something and yet not something at the same time. Like it really gets into the hardwiring of our minds when we think about these kind of, right? And so, okay, so I'm getting off. What's the takeaway? So I can't fully answer yet exactly how light works. I can tell you that certainly by the end of this course, yes, I'm going to treat it as a wave by the end of this course. And I'm going to say it's a wave and it does not create its own medium because a wave can't. And it's not made up of its own particles because a wave can't. By the end of this course, I'm going to say, well, maybe I'll just say the answer now. All right, I'll even say it. Here's one way to think about it. It may help some of you. It may turn some of you off. I think light is a wave, and not always, but I think in most contexts, it's perfectly reasonable to think of light as a wave. I think, therefore, it does have to have a medium. The thing is, what I think the medium for light is, I don't know why I didn't just say this 20 minutes ago. I'll just say this if it means anything to any of you. What I think the medium
the bunch of stuff that is oscillating in order to send a ripple through. I think the medium for light is electric and magnetic fields. And I think fields are the next thing that we're supposed to study in this course for not coincidence. Oh, Peter. Hello, sir.
Spin me.
Spin? Okay, I'm teaching. Spin? What?
On the chair upstairs.
Well, I will. After this class is over.
When is that done?
It's over. Oh my God, I've already taken up half. It's over in 36 minutes.
Okay, I'll be on the porch.
Awesome. Love you. Love you. Okay. Yeah, I'll just say the answer. I don't usually do this at this point, but I think light is a wave, and I think therefore it travels through a medium. I think the medium is something called electric fields and magnetic fields. I think electric fields are exactly what we're going to study next in the class, not coincidentally. I think in some ways that answers the question. And I think there are electric fields and magnetic fields in outer space, even though there's no stuff in outer space. I think there are fields in outer space. However, what fields are, when we start, if you already know something about fields or have heard about fields, or we start studying fields next, you'll see why I am both answering the question and not answering the question at the same time. I'm answering it because that's my answer, is fields. However, fields themselves are a thing, they exist, but I'm not sure that they're material either. So it opens up another Pandora's box. I guess I'm saying, just to be as honest as I can, and I am being honest, to be as honest as I can in this time constraint and so forth. What's weird about light, I think light can be understood as a wave. I think it can be understood as a ripple going through a medium. And remember, ripples are immaterial motions through media. What I think is weird about light is that the medium through which light ripples is itself immaterial. That's the messed up thing about light. That's the super cool thing about light. I'm just going to say that again now. This is a total spoiler alert. I actually think that in like almost 30 years of teaching, I don't think I've ever said this in a class at this stage of the class, but why not? Like, the thing about light is it is a ripple in a medium which itself was already unthingy and created from other thingy things. So light is like 2 levels removed. It is a ripple through a medium, but the medium itself is real, scientific, measurable, analyzable, predictable. But the medium itself is a phenomenon that was created by or given rise to by underlying material things. So the medium is already immaterial, but then ripples are sent through this immaterial medium called electric and magnetic fields, and that's what light is. Maybe that might actually make sense to some of you. And if you sort of can see what I'm saying, or at least see how that would make light fit everything we're saying, but also make light even more fascinating and weird, then you're totally with me. Like, I'm actually not even leaving anything out when I say that. Obviously I'm leaving out a lot, but like, that actually is my answer, is that the deal is that light is a wave through a medium, but the medium is already 1 level abstracted. And that level of abstraction is what we have to learn next in the class. Okay, wait, sorry. Oh, okay. Okay, all right, now I'm going to look in the chat. Wait, so, even before I look in the chat, because of course I'm a little bit embarrassed that I just spent that much time. A little bit, but I'm going to say to everybody, I'm only a little bit embarrassed or a little bit apologetic, because the truth is, once I was spending that much time, I just want you all to know that where I landed is a landing place. Like, that is a thing of this course. I don't know how you write it down. It's not going to be on your exam in 2 weeks, but it actually is meant to be a concrete piece of knowledge. And yes, if what I just said opened up other questions too, good, that I'm not embarrassed by, good. Like, let's all stay curious. But if anybody felt like what I was just talking about was like way outside the class or way to the left, no, maybe not on the exam, this exam, but actually it's the point of the whole class. The point, first we learn about, remember, the whole class about unthingy motions. So right now we're looking at unthingy motions, and we're saying an unthingy motion requires a thingy medium through which for it to ripple through. Then eventually we're going to get to the point where we can even recognize that even the medium itself might be unthingy, as long as it's tethered to something thingy. In the end of the day, all this stuff has to come back to something in space and time. Otherwise, this is all Harry Potter, not science. I'm going to shut up and I'm going to look in the chat, and I hope that, but that was a great question. And the other thing is, I apologize to anybody who thinks I spend too long on these questions, but I want you all to know too, I'm spending this long because of the nature of the question, not because of any particular person who asked it. So if nothing, I hope the rest of you take the message to mean, oh, if I asked a question, it would be honored. Like I would then run the class mentally for 15 minutes. Like, please don't take this to mean like that you shouldn't ask questions because it'll derail us in the future. Take it to mean like we're here to be curious and to care and to love science. If in the end of the day, I can get each one of you to care for 15 minutes or to think like that your questions actually matter for 15 minutes, I'd rather do that than spend all this time on exams and everything, honestly. And then you'd each get an A. Like really, like I wish that, you know, I mean, I think I could have done better. Well, whatever, you get my point. So I'm going to look, okay, but obviously I'm just apologizing. So I'm going to look in the chat and then we're going to go on. And yeah, we do have an exam, which is weird, but okay. Right, okay. I'm seeing the follow-up. I'm going to sort of ignore the follow-up for now because I think I maybe sort of addressed it or I'm not, but centripetal acceleration right now. You mean send me back to the center of the circle? I'm not even sure what that means, but okay. I think it's funny, but I'm not sure. Okay, well, centripetal, okay. Yeah, okay. Oh, okay, cool. Oh, thank you. All right, some of you were saying very nice. Oh. Okay, that's funny. Thank you. I actually totally did not get, I thought you were saying because I was on such a tangent in the conversation. Okay, right. And my son, right. And that's weird. Okay, thank you. That is very funny. Public chat people and direct chat people, thank you. I appreciate in the direct chat that, I mean, you're making me feel like that wasn't like a total waste of your time. I appreciate, okay. Sorry, I have to collect my, all right. Okay, I'm going to quickly say too, from the sublime to the mundane. So we do have to have a midterm exam, right? Like hopefully you saw in Google Classroom, there's a quick posting about the logistics of the midterm exam. And I did that, and I'm not going to, so check the posting in Google Classroom. It's one of those things where you get 9 points for just confirming receipt. And that's not a joke, okay? Just as long as you just acknowledge that you get that the midterm exam will be posted like 2 Thursdays from tomorrow, which I know is late in the semester, and we'll address all that too. Like all this does mean that your midterm is going to be bigger than your final. Your final is going to be more designed for people that need it if they didn't do well in the midterm, blah, 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 blah. Like the big peak of the course is the midterm, okay? The final will be a lot shorter and have a lot less material for sure, because I know we're very into the semester at this point. I'm aware of that. And again, we're going to do something like where if people did badly on the midterm, then I'll weight the final a little bit more heavily for them, like as a chance to do better. If you rock the midterm, then you don't have to get all re-stressed for the final. So like I'm going to slightly weight better, whichever one you do better on, basically is what I'm saying. That's funny. Right. Funny. No, that's funny. No, and you do, everybody does have to take the midterm. The midterm is kind of a big deal. It is, especially if we waited this long for it. But again, the better you do on it, the less you have to stress about the final. Like that's true too, okay? It's 2 weeks, it'll be posted 2 weeks from this Thursday. No, I get the slides. Okay. No, that's very funny. But I don't need your lobster. I do need the Nintendo gift card, but I should be giving you the lobster. No, and look, I mean, believe me, I mean, you could tell I have no interest in grading these midterms either, or whatever I did, but we do have to have it. It will be 2 weeks from this, just to quickly say, it'll be posted 2 weeks from tomorrow, posted for everybody. It'll be it's online. I mean, it's take home. You don't do it under test conditions. You treat it like it's like a, research essay or whatever. You return it by 12:15 on the following Monday. You can work together, blah, 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 but whatever you turn in has to be your own. Like you can only write down things that you understand. Your goal in the midterm is to not give answers, but to prove the answers and prove that you understand them. That's your real goal in the midterm, is to show that you actually understand everything you're writing down, which means in most people's cases that you want to write down a lot more, not a lot less. When in doubt, you want to add extra steps, extra lines, extra color, extra pictures, extra annotations. Your goal is to show that you get that you really get the solutions to the problems that are assigned in the exam, even if you ultimately got them by talking to your friends and going on YouTube, going on 3 Brown, 1 Blue, or going on Khan Academy, like whatever, or going to your tutors or the MSRC. Like, I don't care where you get your understanding and information. And in many of your cases, I know it's not me because I talk the language I talk. It doesn't work for everybody, but you get your understanding wherever you get it from. But then what it is your understanding, and then you convey your authentic, actual, real assimilation of the material in the document that you turn in by Monday, whatever it says in Google Classroom, April, whatever it is, 11th or something, whatever it is. And what I'm asking you, and next week I'll give you a review, or before next week, I'll give you like a practice test that you can use to see what the test is going to look like. And we'll use next week as an opportunity to review or practice or answer questions. Maybe you might use a lab period as well. I'll talk to Professor Johnson. But right, so we have next week to worry about it. The week after is when we actually have 2 weeks to worry about it. The week after is when it's going to be posted. And then it's due back the following Monday. What I'm asking you all now, so I can move on to the topic for the few minutes remaining, is just when you see that Google Classroom posting that's sort of like laying out the expectations of this, just logistics, just confirm, yes, it's sort of like you're agreeing to not give me lobsters or a Nintendo gift card. You're like agreeing that you get that the exam is coming and all of that. And the one thing just to say to everybody, especially if you haven't had me before, as loose as I am on tons of things, I'm not loose about exam submission time. If you know you're going to run into an issue with the exam, if you know it in advance for some like reason, then communicate with me in advance, and we probably will be able to work something out. But you have to communicate with me in advance, like directly, like personally. I'm not saying I'm going to get into your personal business. You might even end up in some of your cases just telling me I have a personal issue that I don't want to discuss. Fine. But the point is that if the exam is going to come in even a minute late, there needs to have been an advanced discussion and agreement about it with me, right? So there are exceptions, there are human circumstances, but we need to communicate them. An exam that just comes in late with no explanation definitely is an exam violation and like does have consequences. Okay, just to make that clear, like it's one place that I am rigid. Okay, so and you're going to confirm your understanding of that, and you're going to get 9 points for that when you just type in yes into the announcements to this effect that are on Google Classroom. Okay, from the sublime to the money. Okay, oh my God, that's so funny. Okay, -9 for me right now. Oh, yes, wait, and I'm sorry. No, this is a legitimate question in direct chat. It is not too late for you still to make revisions or updates or anything on the homeworks. I'm still taking homeworks. I will stick. Again, I haven't given them back to some of you. Like I know the homeworks you do, and especially if they're helping you study, for sure. Yeah, like, but I'm just saying the actual exam itself can't come in late because it's an exam. But yes, you can. Okay, that's funny. Okay, it's okay. What? Okay, wait, I'm looking at chat. Oh my God, you guys. I don't know if you've ever noticed it's so much easier to take advantage of me on a Wednesday because I'm always so tired from this freaking commute. But wait, okay, some of the things in the chat are very funny, but there's some serious things. Let me just, yes, Ward, who by the way was super early for class today, was in the waiting room super early, and I totally noticed that, and I totally appreciate it. Yeah, you have 4 days, like just to be clear. And and I know you didn't have me before. So yeah, and I will say more about this next week, but yes, the exam will be posted on a Thursday and you will have all weekend to do it and to turn it back for that Monday. Yes, you have 4 days to do the exam. And let me reinforce everybody, it's not under test conditions. Like you can go to it and come back. And I mean, you can walk away from it and come back. I suggest you make drafts. Like I suggest you try things and then ultimately copy it over neatly before you hand it in. It's much more like a project or a paper, if you like, than an exam. It's not test conditions. You have 4 days to do it from when it's posted. And before it's posted, you'll even see practice. You'll even know very much more or less what to expect on it, because you'll have a practice document. So it's right. You'll have 4 days to do it. Yes, to answer that question. And then there was one other question that was like sort of legitimate, I thought. Oh, and yes, you could still hand in homework. Okay. Okay, cool. And thank you. No, and I know, and the 5-step, we'll talk about that too. I hear you on the, I know that Walters is not big on the 5-step, or didn't used to be. Yes, I understand. I do understand. I'm trying to, okay. Oh my God, 110. Okay. Okay, sorry. Okay, so let me try. So that's the sublime to the mundane. Let me try to do a little physics for a little while. 20 minutes before I go spinning him on the chair. Okay. Okay, to remind you, to bring this maybe sort of full circle or somewhat circle, we have this wave equation now, right? We've established the one-dimensional wave equation, which in effect says that if you picture some medium, if you picture the slinky in lab 3, for example, so, and here we're talking about a one-dimensional medium, and in fact, tacitly, we're talking about a one-dimensional medium that is stretched along something that we're calling the x-axis, right? So a horizontal medium, if you like. If you picture some long slinky, right? If it can be said that at every single point in that medium, or any and every single point in that medium, and at every and any single point in space, if it is the case that any dot that you pick anywhere in the medium, if at that point in the medium and at that point in time, if the rate at which that little dot, that little piece of, in this case, metal, if it is accelerating along the y-axis back toward the equilibrium x-axis, if the rate at which that little piece is accelerating back to the home axis, if that rate is directly proportional to the extent to which the medium is concave at that point, somebody say that again. If the rate of acceleration of that point is directly proportional to the concavity of the medium at that point, so if the rate at which it's racing back to the equilibrium axis is directly proportional to the extent to which the medium is deformed or disturbed, concave, unflat at that point, then what we have rippling through this medium is a wave pulse. In fact, is multiple wave pulses, is a wave phenomenon. If that equation is true at every and any point, then what we have is a wave. Or conversely, if we think we're seeing waves going back and forth through a medium, as you did in lab 3, then it is the case that at every and any single point in space and time of that medium, this statement is holding true, that the rate of acceleration back toward flatness is directly proportional to the extent to which we are not flat. Like when you really think about it, it makes it's unbelievable how much sense that made to me. Like it's so simple in a way. It's just Hooke's law blown up into a higher dimension of space. We're just saying acceleration back home is directly proportional to disturbance away from home. What is a wave pulse? It's a traveling disturbance. And by disturbance, I don't mean bad mood. I mean deformity. I mean bent. I mean misshapenness of the medium, right? So when we say we're seeing a wave pulse travel, we're saying we see an identifiable shape of disturbance traveling, right? Okay, so that's what this says. But now what I want to unpack for 15 minutes is like, I'm saying that statement that says one thing is directly proportional to another thing. I'm saying one thing is one thing, meaning the second derivative in time, known as acceleration, is directly proportional to another thing, second derivative in space, known as concavity. I'm saying the two are directly proportional because one of them is equal to a constant times the other, right? That's what direct proportionality means, equal to a constant times. So what I want to do now for 14 minutes is talk about that constant, like the constant of proportionality, omega over k squared. On the one end, it's just that. It's just a constant of proportionality. But does it have meaning? Well, I suggest that it does. I mean, in fact, remember in Hooke's law, the original differential equation on which this was all based, we had like d2y over dt squared equals negative omega squared y. The constant of proportionality there, omega squared, turned out to be not just some random constant, it turned out to be the angular frequency, the rate at which the oscillation was occurring. So this constant has omega in it, but it also has k. As an entire package, does it mean something? Yes, it does. So let's look. So balloons. Okay. I want to introduce here the concept of wavelength. You've heard of it your whole life, your whole scientific life. You may know that wavelength is generally denoted with the Greek letter, the lowercase Greek letter lambda. Okay. What wavelength is the distance between any two successive, what wavelength is the distance of one cycle in a wave, the distance from one crest to the next crest, or one trough to the next trough. And I think most of you know that. And it can be seen on a graph. If I make that little wheel, you've probably seen this picture before, like the distance from one crest to the next, the number of meters in a cycle is what we call the wavelength. And it's here depicted in this lower right-hand graph on the page. Well, see, now you're sophisticated enough to understand that whenever you've ever seen that picture before in life, that was just the spatial picture. That was the picture of y as a function of x. What's also happening in superposition with that, if we have a wave like that picture right there is just a snapshot of a wiggle. It must also be wiggling in time for it to be a wave pulse. So at any moment we could make a picture of y versus t, which is the upper graph here on the page, right? And you see when you lay it out like that, oh, wavelength is to space as t, capital T, the period is to time. Like period is the number of seconds per cycle. Wavelength is the number of meters per cycle. It makes sense, right? And we can link them back to our original, to our other slightly more abstracted constants. Omega is 2 pi over the period, right? Angular frequency is radians per second. So omega, our angular frequency, was 2 pi radians per t the period, right? And in other words, how many cycles per second we're doing, but measured in radians. And k was 2 pi, or is, if you think of it this way, k, remember, is to omega as space is to time. Omega is radians per second, k is radians per meter. So one way to understand k is we can think of it as 2 pi over the wavelength, lambda, right? I mean, that just makes it a little bit more concrete, at least in my head. So we have omega is 2 pi over the period, omega angular frequency, number of cycles per second, and k, the angular wave number, the number of cycles per meter, is 2 pi over the wavelength, right? Now, why am I, that's just a way of understanding what omega and k are. Time for the cycle, space for the cycle. But then that means that omega over k, right, is the same thing as lambda over t. Like it's, when you divide fractions, you multiply by the reciprocal, like, right? So like 1/3 divided by 1/2 is 1/3 times 2, right? So the lambda flips up. But so omega over k is radians per second over radians per meter. The radians cancel. We have meters per second. Omega over k is wavelength per period. The amount of space from one crest to the next divided by the amount of time from one crest to the next. It's meters per second. It's also frequently written as wavelength times frequency. That's another way you could write it. In fact, that this is the more common way it's written in books. But I think the more sensible way to immediately picture what's going on is to think of it as wavelength per period. Because once I realize that that omega over k is meters per second of the wave, and specifically it's meters for a cycle divided by the seconds for a cycle. Well, this is just And now that I put it this way, I think I think you saw this with Professor Johnson, and I think we're about to be interrupted. We have 2 minutes.
How much
Look.
left?
4 minutes, 4 minutes. But this is a big clock. Okay, thank you. Okay. Okay, but I have to do this, and then I've got to do this.
Okay.
But yeah, cool. Okay. Wait, wait, don't take that. Thank you. Thank you. I'll give you that soon. Okay. Thanks. Okay. Have a good. Okay. And this, I think Professor Johnson did this with you actually, and it might have been slightly confusing because he used a word that might have thrown some of you off. This V is sometimes known as phase velocity. You've seen this, but this V is just what I just said. It's the number of meters between two successive crests, and it's the number of divided by the number of seconds between two successive crests. So this is just the rate at which, I mean, if you were standing at the ocean and watching waves come in, and if one crest hit you in the face, and then the next crest was 3 meters away, and it took 1.5 seconds for the next crest to come, then that means the rate at which each crest is coming in toward you is 3 divided by 1.5, 2 meters per second. This is the rate at which crests or troughs or any other like-minded part of a cycle, any other phase of a cycle, this is the rate at which they are propagating through the medium. This is the speed of the wave. And I mean, along the x-axis, let's get this straight too. If we go back to the wave equation, the whole point of the wave equation, we've got this left side, like d2y, dt squared, we're saying, remember that the wave is a bunch of oscillators, and each oscillator is moving back and forth and back and forth. At every single moment, each oscillator is changing its vertical position. At every single moment, each oscillator is changing its vertical velocity. At every single moment, each oscillator is changing its vertical acceleration and its jerk and its whip and all that. That was, again, the point of homework 1. Each one of these oscillators is undergoing an infinitely smooth, infinite sequence of changes in all of its types of motion. But that's vertical. That's in the oscillation. That's up and down in their little neighborhoods. What then ends up passing through the horizontal axis, what ends up propagating through the medium is a pulse. And I'm saying here, or we're saying, that pulse does not accelerate or jerk or whip or anything. That pulse propagates through the medium at a constant speed known as V, the speed that is omega over K. In other words, first of all, we're saying, and I know we have 3 minutes, but we're saying 2 very big things here, maybe 3. We're saying, first of all, this equation, which packs so much information into it, okay, here's the last. I know we have a minute and a half. This last thing that I just wrote here is a huge punchline. I'm going to say it. This ties us all the way back to the original question of today's class. Okay, I could go on about this, and I will for hours, but I'm going to say it right now, just in a minute and a half. I'm saying 2 things. Number 1, this equation is fabulous. I mean, we're saying acceleration is directly proportional to concavity at all points in time and space. That's a wave ripple. But now I'm saying that constant of proportionality ain't just a random number. It's the freaking propagation speed squared of the wave. That's already amazing that this much information can be packed into such a small sentence, really. But my bigger point with 1 minute left is the thing that's highlighted at the bottom of the page. I'm saying that speed, the speed at which the ripple goes, that speed, which is constant, by the way, like, and reliable, that speed that at which the pulse propagates through the medium, well, that speed is omega over k. Remember back to the beginning of the semester, omega is, and I see it's 1:30. Just let me finish the sentence and we'll go. Omega is entirely determined by the parameters, by the material properties of the oscillators, of the medium. Same thing with K. That means that once you know what your medium is, once you say it's a slinky made of this metal, or you, well, these Ks and these Ms, or you say it's air at standard temperature and pressure, then what you're picturing is a bunch of air molecules, each of which can only oscillate at a certain angular frequency and with a certain angular wave number, and there's nothing you can do to change that. So the minute you say it's air at standard temperature and pressure, you've literally fixed the angular frequency and the angular wave number, so you have fixed the rate at which pulses can propagate through the medium. Waves will travel at not only a constant speed, but one and only one speed given their medium. That is unbelievable. That's why we can say things like the speed of sound is 340 meters per second. You never hear the speed of a baseball is anything, because it could be anything. But sound, the minute it leaves my mouth, even if I'm running through the air, the minute the sound leaves my mouth, boom, it's going at a certain speed through the air. End of discussion. Nothing I can do to speed it up, slow it down, or anything. If I mess with the frequency, if I increase the frequency, I just lower the wavelength. The speed is fixed. That's another reason we love waves. Okay, it's 1:31. Thank you for being so patient. I will see you next week. Thank you. Yes, thank you guys. Have a wonderful everything. And I'm here for a second to answer questions. Let me just turn off the, hold on. I'm not, you guys have a great, I will answer questions. Let me just turn off the